sharing the role of the geomorphometry bunch, which is dedicated to the science of quantitative land surface analysis. And before I will introduce today's speaker for our second coffee talk, because we have seen so many newcomers coming in, that I will give you a short introduction. Is what are we, why are we doing that one, and also at the end invite you to our upcoming geomorphometry conference in beautiful Iași in Romania. So what are we, who we are? We are a non-commercial, non-governmental association of researchers and experts which are focusing on all things around the digital elevation models. We want to understand or improve our understanding of that one. How can we do it? What can we do with that one? With which techniques, which software we can use it? What are the best digital elevation models? In the terms of doing it quantitative, doing quantitative analysis. You see down there at the bottom right the URL for our website. Please reach out to us, contribute with articles, content to that one if you want to publish something to bring our whole society forward. You can follow us as all good new people in the world in our biannual conference. In a second more for that one, and we have also sessions at EGU, AGU, or other conferences where selected groups of this whole group of people, which you see here, some on the screen, some not, collect and exchange ideas. In this setting, which we have been in the last couple of years, also due to Corona, we learned that virtual exchange is also quite helpful, and that's the reason why we have introduced now from the board as a new thing our coffee talks, which are bi-monthly. Next one is Tommy Hengel from Open Geo Hub, followed later on then with comes to my mind in a second, Peter Strobel from the Joint Research Center of the European Commission, reporting on DMIX. And we have the next two speakers already lined up for coming after. If you would like to contribute, drop us an email, please, at our Gmail account, and we will add you for further consideration. We, as usual, on Twitter, on LinkedIn, data on the Zenodo website, Instagram. So there's a wide variety where you can follow us. What you will see here today, just as a scene setting, we will have a 60 minutes exchange. Today we have John presenting us something like 15-20 minutes. Afterwards, we will have an open exchange. This is your forum where you can bring out your ideas. You can even present your PhD thesis, research ideas, unsolved issues where you would like to have a discussion on one. And at the end, our session moderator will try to wrap up what we have been discussed and what were the main points out of that one. And to bring more people in here, it's learning by doing exercise for all us. Please prevent the event locally. Bring in your PhD students, your master students who would like to attend here, or even students to see what's going on in this world. Last but not least, a big announcement. What is ready now? Our Geomorphometry 2023 conference. The deadline also the website is online. The EasyChair system has been open since the 10th of November. And in the beginning of January, 15th of January, for the moment, we expect that people are submitting their 4-page abstracts, and then our scientific committee will do their work on reviewing them. And so we are looking forward to many proposals from the community for that one. And you see in the lower right a little image there, the aula which we will use for our conference setting there in nice IASI in Romania. And conference dates, I know many of you already need to plan for next year. Traveling is from 10th to 14th of July 2023, with an early registration deadline for the 1st of May. With that one, I'm done with announcing all the things for geomorphometry, and it's also not the main course here today. I just would like to introduce to all of you our main speaker for today. It's Professor John Lindsay from University of Guelph, where I had actually the, how should I phrase it? In my younger years of career, I had an exchange there for 1 year. I stayed at the University of Guelph and worked with some pre-professors before John there in land resource science. So it's really nice to see John here on stage. He's a geomorphometry and geomatics researcher, and we just figured out, John and myself, that we have met as we had much longer hair. We're not as gray as today. We're much younger at the EGU in Vienna. Must be something like maybe 2003 or something like that, or even earlier. Something like that. So, we have also collaborated together on the geomorphometry book, which some of you might be aware. And with that one, I leave the floor up to John now to share his screen and enlighten us in the next couple of minutes on what he is up to and listening to WhiteboxTools. I'm really looking forward to that one. John, the floor is yours, please.
Wonderful. Thank you very kindly. All right, let me see if I can get this to work. I'm on a sabbatical this semester, and so I haven't actually taught in a little while, and my virtual presentation skills are maybe a little down. Can everyone see my screen then? Dennis, can you?
Yes, John, we can see your screen. We can hear you loud and clearly, and I hope that's also for the rest of the people around the world.
Wonderful.
Thank you.
All right, so I'm going to try to keep it fairly brief. I know that that's sort of the goal of these things, to have more opportunity to chat. When I do start talking about Whitebox, however, and geomorphometry, two of my favorite topics, I do tend to yammer on. So we'll see how quickly I can do this. Okay, so to begin with here, I assume probably not everyone in the audience is aware of what WhiteboxTools is. Many of you will be, but maybe there's some details that I can provide about it that you may not be as familiar with. So first off, what is WhiteboxTools? WhiteboxTools is essentially an advanced geospatial analysis backend application. So it's not, it is at its very root a command line application or a command line interface application, and it's intended to then be married to different front ends. It is open source, so it's distributed under an MIT, very permissive MIT open source license. It is entirely coded in Rust. Rust is a modern systems programming language, much like C or C++, but with far fewer footguns, as programmers call it, less security risk in terms of vulnerabilities, security vulnerabilities. And the code is available on GitHub if you're interested in looking at it. As I said, it's a command line interface application, but no one really, other than one of my colleagues, interacts with it in that way. Everyone interacts with it through one of the many front ends that exist for it. So for example, there's a front end that allows it to interface with Python or R, and there are front ends that can plug it into existing GIS like QGIS and ArcGIS. I shouldn't take credit for any of those. They're all maintained by various people in the community, some of which are actually here today. So that's how people generally interact with it. The one front end I do actually maintain is the Whitebox Runner, of which I'm excited to say we're about to release a new version of that. Where did it come from? So I've been developing geospatial analysis software since my PhD, effectively, way back when I first met Hannes all those years ago. I was starting to write this type of software. And so the first stab at this that I had was a sort of GIS referred to as the Terrain Analysis System, or TAS. It was my very first thing that I ever programmed. And while it eventually developed quite a large user base, it had many defaults that are many, I guess, defects that are perhaps reflective of the fact that I was very novice at programming at that point. So around 2009, I started to develop, when I moved back to the University of Guelph from the University of Manchester, Whitebox Geospatial Analysis Tools, or Whitebox GAT. And that was, again, a desktop GIS application. It also developed quite a large user base. However, around 2017, there started to be issues that I had with it, in particular because it was programmed using the Java programming language, which started to be much less supported as widely than it was in the early days when I started that application. That became an issue. And in particular, the user interface library built into Java that I used called Swing was no longer being supported by Oracle. And I faced a couple of pressures, one being that a lot of people wanted to be able to use the functionality of Whitebox GAT, not in the front end itself, in the GIS that I had written, but rather they wanted to be able to plug those tools into other GIS, which you couldn't do with it written in Java. And the fact that I didn't feel like writing in another entire new front end for it out of some other library that may well have been at some point Oracle killed as well. And so from that emerged the idea of creating WhiteboxTools, a backend application focused on functionality, which then could be easily integrated into other things. So that started in really the end of 2017, beginning of 2018, and that's the WhiteboxTools program, or WBT, that I'm going to be talking about today. And in fact, just last year in 2021, so just a little over a year ago now, we started a startup company called Whitebox Geospatial Inc. with the goal of being able to support the ongoing development of it. You can find us online at whiteboxgeo.com. The philosophy of WhiteboxTools is a little different than most other open source software, in fact. So I think it's probably worthwhile talking about the design goals, and it helps to explain some of the ways in which, or some of the characteristics of the program as you use it today. So first and foremost, and I should say these aren't in any particular order, but one of the high priorities for us in developing WhiteboxTools is code transparency. And by that, I mean more than just open source. WhiteboxTools, the term Whitebox, it comes from the idea of transparency. I think of it more as open access rather than open source. And when we talk about open access, what we're talking about is trying to remove barriers from users. And in this case, trying to remove the barriers from users from being able to access the information contained in the code base itself. And a manifestation of that is the view code button that you see. I don't know if you can see my pointer or not. Maybe if I put it on a laser. So the view code button is not in all of the front ends, but it is essential to the notion of code transparency, allowing users to be able to very quickly visit the code that is responsible for making any one tool operate. Another part of that is writing it in a specific way. So, for example, while it's common for programmers to divide the logic of something as complex as, say, a sophisticated geospatial analysis tool into multiple files, with WhiteboxTools, I try as much as possible to put the business logic, the thing that makes the tool work, in one file, so that when you press that view code button, you're seeing everything that makes that tool work in order to make it easier to understand what's going on. And of course, extensive tool docs. The documentation, user documentation, is really quite extensive for WhiteboxTools. If that's available online as well. And again, each of the tools linked to that. Also, one tool, one function. By this, I mean, I don't like to create tools where, you put in one DEM and you get like 32 outputs, which is, a common format for other types of software. But for WhiteboxTools, I like to try to keep it as approachable for users as possible, which means one tool, one function, ideally. You want to generate slope, look for a slope tool. You want to generate curvature, look for a curvature tool. And rather than them being embedded into other tools. That's a philosophy that we have. Develop for speed first. There's a compromise that exists in development between memory consumption and speed. And given that compromise, I'll always develop for speed first and memory second. That said, memory is very important, and I work as much as I can to try to reduce the memory footprint. But back when I started Whitebox GAT, it looked as though memory would be something that would increase substantially. Then we had cryptocurrency and memory became much more expensive. but there is signs, at least, that we're going to be returning to a point where computer memory is much more much less expensive and much more expansive. No user installed dependencies. This is a big one. So it is pure Rust. And again, this comes out of an experience that I have where I'm not going to name names, but certain GIS working on Mac as I do, it can be quite challenging because you have to install many different dependencies in a specific order before you can actually get that GIS working. And this has always been the case for TAS, Whitebox GAT, and WhiteboxTools. You can just download the exe and run it. There's no dependencies. And again, that comes, as with the previous one, with certain compromises that need to be made that have implications for characteristics of the program itself. And then lastly here, and by no means last in priority, is innovative functionality. So a lot of the things that I focus on in creating in WhiteboxTools is unique to it, that sort of pushes the boundaries of the various geospatial sub-communities that I'm targeting with the creation of each of these tools. I hope to give some examples of that today. In terms of the Whitebox platform, so WhiteboxTools is essentially what we refer to as the open core. It's the foundation, the open source project from which this has started. As I said, we started a startup company, or launched a startup company last year, and that obviously needs to generate revenue. I'll talk later on about why that is. But essentially, the idea here is to be able to sell sort of add-on products that help to sustain and to support the development of that open core. Everything is about the open core. And so we have a series of extension tools. So there's the Whitebox toolset extension, which contains about 65 proprietary tools. And we sell those at annual and perpetual licenses in order to generate revenue to support the project. We also have recently launched, and this one I'm quite excited about, just this past summer, we launched Whitebox Workflows for Python, WBW. Whitebox Workflows for Python is a native Python extension module. Essentially, we're taking that command line application and completely rewriting it in a way where it is a native Python extension. And that means that Python can speak to Whitebox Workflows directly, can pass objects, data objects between Python and the Whitebox code. So it's essentially a library rather than a command line application. And this makes writing Whitebox-based Python geoprocessing scripts really easy and much, much more powerful. It allows really low-level manipulation of data objects like rasters, vectors, and LiDAR data. At the side here, I have an example of a WBW script doing some basic geomorphometry, taking in a LiDAR data set, interpolating it into a DEM using tinning, filling in the missing data gaps that there might be, smoothing that data, removing the depressions in it, and performing flow accumulation, all in about 10 lines of code. It's pretty remarkable, and I have to say we're pretty excited about this one. It's $10, by the way, for users. So we've tried to keep the price really low in the hopes of being able to get more people using it, because ultimately that's the goal here. In terms of functionality, so if I can get now into some of the more functionality of that we're hitting. So it does have at present, between the open core and the extension tools, about 540 or so tools, about 88% of which live in the open core. And those tools target a wide range of geospatial processes, things like vector data analysis and so on and so forth. But in particular, of interest to us in this talk are its functionalities that are listed around LiDAR data processing and remote sensing, DEM generation and DEM pre-processing, spatial hydrology and stream network analysis, and of course, geomorphometric analysis. And because of my background in these particular areas, these are core functionalities and make up a large part of what WhiteboxTools is essentially. So let's take a brief look at some of these areas. And I'm just going to highlight some of these things. So to begin with LiDAR data analysis, I don't really have time to go into all of what Whitebox does, but just to list some of the functionality. So there is, of course, the ability, as I showed earlier in that WBW script, the ability to interpolate LiDAR data. And this, I should say, includes a number of methods, standard methods like IDW and pinning and nearest neighbor and natural neighbor, splining, so on and so forth. But these tools are specifically geared to working with LiDAR data. So for example, you can interpolate the various parameters of the LiDAR data set, elevation being the obvious one, but also things like intensity and the return number and RGB values that might be associated with it. You can interpolate by excluding or only including, first returns or last returns or all of the returns. You can exclude points based on their classes. So you can, in that previous script, may not have been obvious, but I was excluding all vegetation returns and noise returns from the interpolation. So they are very geared towards interpolating LiDAR data. Additionally, we have things like directly contouring from the LiDAR data. So you don't have to interpolate the DEM and derive a contour, which you can do, obviously, but you can contour directly from the LiDAR data. We have tools in there to filter LiDAR data, and by that I mean filter based on any property of the points, RGB value, intensity value, any of the properties associated with the points you can filter. You can also modify those points directly. You can split LiDAR data up into groups based on, again, point properties. You can sort LiDAR data. You can derive some basic point features, including the eigenvalue features, which I'll show an example of later on. You can normalize the data set so that you're really measuring in the elevation parameter the height above the ground. All of these types of things. Example of this is a tool that recently released called Colorize based on point return. Some of the names in WhiteboxTools are a bit lengthy, I'm afraid. They are intended to give exactly what they do. Again, that 1-to-1 function idea. So here we're colorizing based on whether it's a last return or first return or intermediate return or only return. Helps to visualize for quality control, obviously. We do have a LiDAR point classification functionality, so you can classify ground points and vegetation points, all of the standard things. I plan on adding some machine learning based very soon point classification as well in order to enhance some of these capabilities. This is the example of the eigenvalue features, so measuring for each point the linearity, the planarity, and sphericity, and a few other derivatives as well for points that help with classification for sure. Surface flow. So in terms of modeling surface flow or hydrological applications, WhiteboxTools has fairly extensive capabilities here. There are a number of commonly used flow accumulation algorithms, including obviously things like D8 and Rho8, but also more sophisticated things like D infinity, MD infinity, or multi-direction D infinity are integrated into WhiteboxTools, allowing people to see alternative ways of dealing with things like flow accumulation. And because of that view code, you can look at how it's actually implemented. Of course, watersheding capabilities, things like mapping catchments and hill slopes, straler order basins, isobasins or equal-sized basins, all of those types of things that you would expect. Sink mapping, identifying depressions, stochastic depression mapping, that's what PDEP is, that's what this image at the side here is. So this is used pretty commonly in wetland mapping applications. That actually comes out of my PhD, the PDEP index. Lots of other hydrological land surface parameters as well. Things like wetness index, of course, and sediment transport index, but also some more or less common things like depth to water. We have a hydrological connectivity index that's based on a modification of some of the work that Stuart Lane did, the downslope index, and one called the impoundment size index, which I have yet to publish. It was on my things to do on sabbatical, but didn't get there, unfortunately. In terms of surface flow modeling as well, obviously, before you can apply those algorithms, typically you have to do a fair bit of DEM pre-processing, and WhiteboxTools, again, offers a fair amount of options in this case. So efficient depression filling, and the thing that I'm most strongly known as advocating for is constrained breaching, or at least cost constrained breaching. Of course, each of them have different impacts in terms of the DEM, and at least with modern fine resolution DEMs, it's often the case that constrained breaching provides a lower impact solution to these problems. Stream burning, including, again, not just standard stream burning, but some more sophisticated algorithms. For example, there's a tool in there called Burn Streams at Roads. Again, try to choose names that say exactly what it does. So this is a tool that will deal with this issue of road embankments in fine resolution DEMs, where it finds the intersection between roads and streams in terms of the stream vector, and then it'll just burn upstream and downstream of that road embankment and cut through it in a more efficient way. We also have algorithms to actually remove road embankments from fine resolution DEMs. This comes out of some work that I had with a master's student of mine, Nigel van Evenhausen, so, you know, there are plenty of sort of unique, innovative solutions to these types of problems. Surface curvatures. This comes out of stuff Peter will recognize. So in the last year, I've revised all of my algorithms and enhanced my algorithms for deriving surface curvatures. So at this point, we now have 18 surface curvatures and curvature indices in WhiteboxTools between the open core and the extensions, including some more unusual or less commonly available in GIS options, things like ring curvature and rotor and curvedness, which is wonderful, by the way. Curvedness is truly a wonderful index. Generating function, shape index, and unsphericity, which also is pretty marvelous. Each of these have come or are derived using the robust method described by Igor Florinsky, 2017, in his wonderful book on this topic. And that's the case for projected DEMs. For DEMs and geographic coordinates, I use the technique that he describes there that's based on a 3x3 window. We also just recently, as in last week, I added a tool for calculating multi-scale curvatures. So each of those 18 curvatures that I described previously, we now have the ability to measure in a multi-scale fashion using a fast Gaussian scale space. We can effectively calculate any particular curvature at any particular scale for an input DEM. And this is particularly useful, obviously, for dealing with rough surfaces, where when you're calculating curvature, you probably don't want to know the curvature of the micro topography captured in that fine resolution LiDAR DEM, but rather you'd like to know the curvature of the hill slope that little, bump lies on. Speaking of rough DEMs, we also have methods, obviously, for smoothing DEMs, not just the typical sort of remote sensing solutions of applying a low-pass filter, of which we have plenty, including some fairly sophisticated low-pass filters, but we also have methods specifically geared towards smoothing DEMs in an effective way. So this comes out of some work with a former master's student of mine, Anthony Francione, who may be here and is now co-founder of Whitebox Geospatial Inc. But anyhow, he and I developed this method based on an earlier method that was applied to meshes, DEM meshes, or three-dimensional meshes. And the idea here is to be able to preserve, so to smooth the roughness while also preserving the sharpness of the various edges in the DEM, which you don't get when you apply typical low-pass filters. They tend to obliterate the sharpness of edges. So we notice that this particular LiDAR DEM, which was captured under very heavy forest cover, is very rough. And after applying this algorithm, we've removed most of that roughness on the hill slopes while also preserving the sharpness of these, say, scarp faces that we see here, or of the cut banks of the stream, all perfectly preserved. We've recently added the ability to map break lines. So you input a DEM, and the output is a nice smooth break line vector map, which is a tool that we're pretty pleased with in terms of the performance. Very helpful, obviously, for geomorphometric, particularly geomorphological, I suppose, interpretation of landscapes. This is a contribution that one of my former PhD students, Dr. Dan Newman, added to the tool base. So he contributed the Geomorphons tool, which is I should say, pretty fast, given it's written in Rust, implementation of the Geomorphons methodology. If you're unfamiliar, this is a fairly widely applied landscape or landform classification method in the geomorphometry community that can break landscapes up based on essentially a line of sight analysis. It's a pretty clever algorithm if you've ever taken a look at it. It is multi-scale inherently because it uses this sort of line of sight method, and it's pretty efficient as well. Produces very decent results. Speaking of line of sight, in terms of visibility analysis, obviously we have hillshade, as do most GIS, but we also have a tool in there for multi-directional hillshade. This comes out of the fact that the traditional Horn 1981 hillshade algorithm has the issue of really underexposing certain areas and overexposing other areas. Particularly these days where we have fine resolution DEMs that we're often deriving a hillshade in order to overlay on top of other layers, those areas of underexposure can be a real problem. And so at least for visualization purposes, a multi-directional hillshade where we preserve some of the detail within those shadow areas can be quite useful and can actually produce, in terms of visual quality, visualization, outputs that look nearly as good as those sort of classic Swiss hand-drawn relief maps. So this is one that we're pretty pleased with as well. In terms of visibility, again, of course, the classic openness index of Yokoyama 2002. So we have a tool in there that can be used to calculate essentially exposure, landscape exposure. And it comes in two flavors, of course, if you read the original Yokoyama paper. So there's positive openness, which is describing the openness, the visibility of a site looked at from above, and negative openness would be looked at from below. And so this is, again, a fairly efficient tool that we have in there. Of course, other visibility, so view shed analysis and whatnot are also included in WhiteboxTools. The one that I'm probably most proud of is an index that I came up with a couple of years ago now called Time and Daylight. Time and Daylight effectively takes an input DEM, or really ideally a digital surface model, as we see here on the left. So we've taken an input digital surface model and calculated time and daylight. Time and daylight effectively measures shadows within the landscape across a range of time. So you essentially input a range of time and it calculates the sun position over that range of time, figures out all of the shadows, and then the output raster, which is this time and daylight raster that I have. Essentially, the dark areas, the values of near 0 are areas that are never in light, they're always in shade. And the areas closest to 1, or the brighter areas, are places where, proportionally speaking, they're much more commonly in sunlight. For covariance used for insolation modeling, or for modeling that involves solar radiation, this is a really good index. It's also a really good index, by the way, just for visualization. So here on the left, we have traditional hillshade. This is in fact just the traditional, not the multi-scale hillshade or multi-directional hillshade that I talked about before. And on the right, we have time and daylight. And in particular, when we're dealing with urban areas where there's a lot of off-terrain objects, so a digital surface model, that 3D nature that we all lean so heavily on hillshade for, time and daylight just does so much better for, I find. So I haven't overlaid here a DEM, but the combination of a DEM and time and daylight map looks really nice in terms of visualizing that pseudo 3D nature of the surface that we're modeling. And of course, we can go one step further. So WhiteboxTools also has a wonderful tool called shadow animation, in which we take this three-dimensional, and I really hope that this animation is popping up. I know Hannah said in an earlier preview that it didn't show up, so hopefully you're not just seeing a dark screen on the right here, but we're capable of taking that and again, using the same sort of technology to generate outputs that are animations of shadow over any length of time. So this particular image that we're seeing here is a farm in which we're seeing the shadow animation. This was because of an interest in being able to model whether or not hedgerows are affecting the growth of a crop. Farmers these days with improved tillage practices no longer need to use those hedgerows as windbreaks, and so many of them are wondering whether they can remove those features and enhance crop production. Of course, that's not great from an ecological point of view, and so there are people who are interested in being able to actually quantify, well, what's the net impact in terms of solar input to a field. And this is quite a useful tool for that purpose. Also, these tools, time and daylight and shadow animation, wonderful, and a lot of people looking at them from perspective of solar mapping. All right, not much time left to go here. So multi-scale surface parameters, this is something I won't have a lot of time to talk about, but it is a huge feature of WhiteboxTools. So Here, of course, on the animation that you can see, we're able to extract things, in this particular case, local topographic position in the measure of deviation from mean elevation, in a way where each frame describes different scales at which we're measuring that. And as you can see, in complex landscapes like this, different landforms pop out at different scales. We have the ability in WhiteboxTools with many, many different land surface parameters to take that scale stack that we saw each frame in that animation on the left, and on a pixel by pixel basis, measure the scale signature of a land surface parameter and identify characteristic scales. We then collapse that scale stack for each pixel with each characteristic scale in a way where we create what I refer to as a LSP scale mosaic. And these LSP scale mosaics, like what we have on the right here, have the ability to represent complex landscapes that have many different landforms at different varying scales in a much, much better way than the traditional multi-scale approach of just modeling at many uniform scales. I won't have time to get too much into this, but I wanted to show this as an example. So here we have a complex glacial landscape where we have a drumlin field superimposed over top of fluvial landforms, over top of bedrock outcrops, and of course, a scale mosaic, in this case of deviation from mean elevation, can represent that detail much, much better. We can do this also for curvature, for many different common land surface parameters. Lastly here, though, I have elevation percentile. This is a elevation percentile land surface parameter scale mosaic, looking at gullying of an upland peat area in between Manchester and Leeds. Those gullies are of widely varying spatial scales in terms of their width, and a scale mosaic like this allows us, therefore, to map those gullies in a way where no single scale, uniform scale, would be able to capture all of that detail. So if I can summarize now, WhiteboxTools is essentially built on a long legacy of geospatial software that I've been developing over the last 20 years, with a real center around geomorphometry, given my background. So the functionality here is uniquely geared towards this. Unfortunately, this is just sort of the tip of the iceberg in terms of the functionality. I've tried to highlight some of the things that are perhaps recent or more interesting to me, but I've not been able to cover a fraction of its capabilities, unfortunately. If you'd like to learn more about it, you can download it, obviously, from whiteboxgeo.com. You can look at the help documentation. The user manual is up there as well if you want to take a look. And of course, you can look at the source code. And lastly, if I can say, obviously, I said we started a year and a half ago, started a company with the goal of being able to support the open source development. And from that perspective, financial contributions are certainly very welcome. You can do that by purchasing. We have sort of a pay what you can model for the open core. Most people obviously just press 0 and go on, but we do get people who donate every day, which is very useful. Buying extensions, as we mentioned before, or the Whitebox workflows, which is again only $10, and wow, it's pretty fantastic. All of that money goes towards sponsoring or goes towards the development of the open core. Lastly, the sponsoring of an open sourcing tool. I can't talk too much about this, but there's a Canadian government agency who is currently sponsoring the open sourcing of some of the tools that are in the extension, which is a wonderful way. All of this, the goal is effectively to be able to hire a full-time employee who can then support the user community, which we're not quite there yet, but we're hoping to, early days. And then lastly, code contributions are obviously very welcome. Again, they do need to be in pure Rust, which is, I suppose, a bit of a barrier. One of the easiest ways that you can contribute to the project is to contribute a new tool, which I gave some examples of, like the Geomorphometry tool earlier. All right, I will leave it there, and apologies if I know I have gone over. I think you're muted.
I am. I'm in the year 2022, and I'm still muting myself.
I'll do it.
Or forget unmuting it myself. Okay, thank you very much, John. Really interesting presentation, I think, for me, for others. There's a couple of questions already in the chat. I will ask just for the floor. If you want to have the floor, for interactivity, please turn on your video, raise your hand, I will give you the floor, and then we can have a discussion with John here, and he can answer any questions he might want to ask. Until someone has pressed that button. There was a question from Elle. I'll maybe read out one of the chat questions here now. Is there any function for addressing surface roughness, for example, desert pavement classification?
So I don't have a desert pavement classification tool, unfortunately, but I definitely do have multiple tools, and they're including multi-scale tools for measuring surface roughness. And in fact, those of you who were at Geomorphometry 2018 may remember me actually presenting on that particular topic. So yes, there's actually a fair amount of functionality in there for dealing with roughness. And of course, roughness can be a key covariate in, say, a classification, of which we have multiple methods for classification, including machine learning tools like random forest. So those can be covariates that go into creating a desert pavement roughness classification for sure.
Okay, cool. I don't see anyone with their hands up for the moment. Just for the record, we
probably
have
a little overwhelmed.
yeah, I mean, this is fine. Is there, okay, from Diago Cabral? Sorry if I mispronounce your name. You may I will buy you a beer next time we see in Yassi. Is there a function for extraction of lava flows using only the land surface? Do you have something in the toolbox? Is there something you can advise?
So again, I'd say I don't have a lava flow extraction tool, unfortunately. Although, I mean, don't be too surprised if there are such niche tools in there. There definitely are many that are very specific. But again, I would say that, with the wide range of land surface parameters that WhiteboxTools is designed to extract, and with the classification methods built into it, like random forest classification, you can no doubt create such a tool yourself effectively.
Okay, cool. So I think there's two questions related closely. Will we share the slides of that presentation, and will be there a dedicated Whitebox tool training available or planned in the future?
Good questions. So the slides, I think that this is being recorded, and that will probably be up there. We can also upload the slides to whiteboxgeo.com. So Anthony and I will do that probably later today if people like, and make them available. I'll put it out on Twitter or whatever. In terms of training, so again, there's the user documentation, which is very, very extensive. We have a number of YouTube like tutorial videos that we've been creating. We've been trying to do that quite a bit more lately. I've been getting involved in that pretty heavily. I would like to do a workshop at some point. I've been approached a number of times, and in fact, Geomorphometry 2023 might be a perfect place to do a WhiteboxTools workshop. I know I can be on the hook for that one. So I would like to offer some things like that. For Whitebox workflows, this is something that I think is uniquely suited to instruction. So I will be teaching with it this next fall for remote sensing and environmental modeling. And I'll probably take those labs that I write with it and make them available to the community as instructional resources.
Cool. Now the chat is exploding. We don't have so many people asking for the floor today, but I mean, I'm trying to read out of them one. So, question from Adrian Krieger. He was commenting on that you're using quite a lot of LiDAR data. What's your performance with low resolution elevation products like? So if you're talking SRTM or GTopo, I see Carlos is upcoming and has raised his hand. Carlos, I give you the floor after the next two questions.
Okay, so I, in my own research, tend to focus on fine resolution LiDAR data, just because of the nature of what I research. And so a lot of the examples that I gave here were obviously geared towards LiDAR. There is definitely functionality that is also geared towards, coarser resolution data. And there again, I would say that the recent addition of the curvature tools in such a way, and many of the other tools, I should say, in such a way that they deal with data in geographic coordinates rather than projected coordinates, is again sort of geared towards that use of coarser resolution DEM data.
Okay, Cool, because I think that would be cool because it goes in the same direction, I think, which USGS is asking you if we could get WhiteboxTools ready for cloud platforms like,
Yeah, so working at global scale for sure. So people are already using it at global scale, I should say. So some of the multi-scale tools that I talked about here, people have applied to at the, the entire scale of continents, and in fact, the globe. So it's been used for like mapping all of Australia as an example. Cloud. So the cloud is something that I don't see any reason why we couldn't get WhiteboxTools working on the cloud. And I think some people probably already have. It's not an area that I tend to work in. So I haven't been paying too much attention, but we definitely can, I think, get it up and running in the cloud. Being written in Rust, it also can be essentially, it's not yet there, but we could make it into a web application. It certainly can work on the web. Rust compiles to WebAssembly very easily. So, moving into the cloud is, I think, something that's certainly feasible.
Yeah, I mean, you could easily trade from at least what I've seen from Python and Rust. You could bring it up in Amazon Lambda or something like that function, and everybody can use it. We stop here. Yes, please workshop. Jessica, yes, I think we have John on the hook to apply to make a workshop in YASI for the Geomorphometry 2023, and so you all are invited to attend then John's workshop, and we have a win-win situation. We have more people at
happily do that,
and happy for John then to promote further. So I hand over now to Carlos. Carlos, floor is yours. You have hand up for, please, your question for John.
Thank you, Hannes. Can you guys hear me well?
We can. Yep.
Great, fantastic. Hi, John. Great to see you again.
Hi, Carlos. Wonderful to see you once again.
Yeah, glad that I could catch up. I got a bit late on the talk, but I think I got most of it, and it was fantastic. I mean, I was so happy to see that the multi-scale curvatures are already available. I was waiting for those to be available. I mean, we were there,
so I'm going to release them probably later this week or early next week.
Oh, it's okay. It's a Christmas gift for everyone, right? So you got me really interested in those shadow tools. And I was, because I have some people working just my next building, they work a lot with solar power, so that would be interesting for them. And I was thinking if you actually involved some of astronomical calculations in these tools, so you can really model the variation of shadows anywhere on Earth, any time of the year, because they will be different. And then we can see changes in summer and winter, for instance.
I mean, the way that it works, all of the shadow tools work, is effectively to marry horizon angle, which no doubt you're familiar with horizon angle, with a solar almanac. So like you input a data or a date range, and it can be a single day, it can be a range of part of the year or an entire year, and it calculates essentially the sun position at all of those times. Sunrise, sunset, and then it's sort of figuring out what the shadow would be. It's just a really efficient horizon angle algorithm that's built into it to allow this to happen effectively. And so yes, this is effectively how it works. It is being applied for solar power mapping in cities, and in particular that ability to say, let's just look at the potential, say, in the morning or in the afternoon is attractive to those applications, because a lot of it is about being able to prioritize where we put solar rooftop solar installations in order to offset or to deal with the peak in demand. So, if the peak in demand is such that it's, midday or whatever, then we can find houses where the exposure of their roofs is optimal for midday. All of that can be done in this particular tool, or range of tools.
Okay. Fantastic. Well, thanks, and also thank you for proposing the workshop. I will be there for sure.
There's no pressure on me now. I have to say, while I'm fully on board for doing this, I did just submit my renewal for my NSERC grant, and a lot lies on whether or not that is renewed in terms of my ability to fund going to Romania. But boy, do I want to be there. So
I'm sure it will.
Next one. Thank you, Carlos. I hand over to Quinn. Please, floor is yours.
Hi. Thank you. Hi, John. It's very impressive that Whitebox have been have changed from a small digital analysis tool to be, I think, is a small size GIS. It's really impressive. And I also note that currently you have implemented so many, several hundreds functions in this software. So I note in one slide, you can, in Whitebox, people can enter the keywords to search for some function. And I think also it also should have a classification of the functions to guide the user to find the function, what they want to use. Still, I think like currently you have you have implemented 18 curvatures for curvature calculation for almost a similar function.
So it actually, for Whitebox, I should say this. So this is the new Whitebox Runner application, and it's not yet publicly released. With the next open core release, which will be in the new year, probably January, this will be available. But yes, so you can curvature, and then I don't know if you can see it or not, but the keyword functionality, you can type in DEM or curvature, minimal. And it will tell you sort of what it does. It searches tools based on not just the name, but also the help and the description of the tool in order to allow people to discover it more. We also have the ability to pop up recently used tools, and of course the toolbox. So yeah, I said that I wanted to get out of the sort of front end game when I created Whitebox Tools, but I find myself once again creating this new front end.
Okay. May I ask a formal one?
Go for it.
Okay, thank you. So if for a novice user, when he want to calculate the curvatures and find there is 18 curvature algorithms in this system, is there any suggestion or consideration to suggest which one could be fit their application? Thank you.
Yeah, so I mean, that's a good question for sure. I understand, because it can be overwhelming, right? 540 tools can be quite overwhelming. Here again, I mean, what I would say is that we have effectively created, I think, a very, very extensive user manual. So, for example, for Gaussian curvature here, we have a pretty descriptive and extensive documentation on what it's used for, what it's good for, with an example of what it looks like. You can compare that to, say, curvedness here, where again, it sort of describes what it is, what it's for, how it can be used. So this is honestly one of my, I don't know if I'd say pet peeves, but one of the things that like we put a lot of work into the documentation, and we try to make it so that the documentation is as easily accessible as possible. But it's commonly the case that users don't always read the documentation. But I can't think of any other way of making it obvious as to, with 18 curvatures, what do they all do, other than putting just extensive documentation there.
Okay, good. Thanks, John, for this answer. Thanks, Quinn, for the question. I think this is also good for everybody to remind. I have 3 more questions for you, and then we will be wrapping up, because we are approaching the hour. So there's a typical question which we have seen already. Is there some function for relative tectonic activity? Have you considered making art from your images? And is there a multi-scale break line algorithm?
Oh, okay. Okay, so
to begin with,
sorry, what was the tectonic question?
Is there some function for relative tectonic activity?
So
I have no idea. Sorry, I'm missing relative tectonic activity. I have no idea what that is.
I won't lie, I'm not that familiar with what that would be, but this is where giving talks like this is quite useful. When people say, oh, is there a tool for doing this or that, then I take those ideas and sometimes they formulate into future tools. So if you really feel passionate about that, reach out to me, and I can certainly do that. Carlos, you have some insight into a tectonic. Is that why your hand is up?
Yeah, it is. I mean, I missed the question in the chat, but there is a method developed in Russia in the 60s called ISO-based method by a Russian called Filosofov. And we've been using that in Brazil, and we can catch recent tectonic activity.
Is this like a hypsometric curve kind of based?
No, it's based on contour levels. So
okay.
You can see variations in the contour levels where you wouldn't see in a normal map. And those may indicate
here I would say
shapes.
again, forward it to me, Carlos, if you don't mind forwarding that paper to me, and it may well become a tool. And you know that's the case because some of the things that you have written about have become tools in Whitebox tools. You know, when I read a paper and I get inspired about it, the first thing I want to do is implement it, right? And
it is a simple method, so I'm pretty sure you're going to do it
then
really
by
easily.
all means, I'll happily incorporate it for sure. The second of those questions, I won't lie, I can't remember now.
Okay, I'm reading out the question one after the other, so it's much easier for you. Okay, have you considered making art from your images?
Oh yes, art. All the time I think about that. So the secret here is that my father was an artist, and so like visualization I take really, really seriously. Like I'm constantly thinking about palettes and all of that. And I do really think about the aesthetic appeal of some of the outputs of the things that I create. And my wife and I often joke that I'm effectively just an artist that plays around with bits. And so, yes, you know, so particularly those multi-scale functions, they can produce some really stunning outputs. And I'm constantly, you know, working with data, and then sometimes I'll like throw up an image that I think is just stunning on Twitter, and you know, just see if other people appreciate my aesthetic or not. But there is definitely an artistic output. Last question there that you had.
Yes, multi-scale breakline.
Yeah, so the breakline tool is really new. Like I think it's maybe about 3 weeks old now. It is based on essentially taking the curvedness output. I talked about curvedness as one of those 18 tools, and then essentially coming up with a clever way for thinning the curvedness outputs and then vectorizing them. Again, it's really quite unique to that application. Now that we have the multi-scale curvedness tool, well, we have the multi-scale curvatures tool, which again, I'm going to release probably later this week or next week, but curvedness is part of it. So we have the ability to measure it at multiple scales. Then one can assume that the next step would be then to take the breakline tool and also make it multi-scale as well. So it doesn't exist yet, but I could certainly see how we would embed that information into it.
Okay. Thanks, John. There are 2 more questions from Andre and Neshlian Dal, which are, I think, for deeper applications. I suggest, Andre and Neshlian, you are contacting John directly, and you get the blessing from Charlie Jackson. The aesthetics of TAS and Whitebox GAT was largely responsible for my passion for geomorphometry.
Oh, that's very true.
This is really nicely said. I should have actually put it after my conclusion of the talk today, and maybe next year, maybe each of us can contribute to the 30-day map challenge from the geomorphometry point of view, because this is where people were contributing for every day in November, making a map on a specific theme. Maybe we should come in as a society as well.
That's a brilliant idea.
Yes, John, thank you again for your presentation today. We are rounding up. We are at 58 minutes because we started 2 minutes after the hour. So let me have my 2 last minutes here, trying to wrap up for that one. Thanks, John.
Oh, I think you might have just cut out.
Did we lost Hannes?
I think we might have. Boy, that's awkward.
No, he's. Oh yeah.
All right. Well,
I'll take over.
Yes.
Thanks, John. That was a great talk. I think you know, I hope you realize the impact that your tools across the years have had on the community. I think they are very useful. And this, yeah, I mean, we can see with the amount of participants we had today that there's definitely an interest. So thank you, John. Thanks everyone for attending. And I put the link in the chat for the website for our next conference, which will be in July in Romania. So I invite you to look at the abstract submission that it will be due in January, I believe, January 15th. So thank you, everyone, and have a good rest of your day.
Thanks, Vince.
Thank you.
Thanks, everyone.
Good to meet you in Romania.
Can you still hear me?
Thank you.
Can you? Ah, now I'm. Hello.